So it's recording.
Just want to swivel back.
Yep.
They said, and I started to I was looking for an income, but I didn't see it. It's on the DEC. Oh, okay.
Okay, good morning, everybody. Good morning, regions. Can you mute your phones in the region?
Good morning.
Good morning. We should have the presentation for the regions up in a minute here. But we're going to get going. We've got a lot to talk about today. Thank you, everybody, for coming. Welcome to the monthly Sustainability Forum. This is part 2 of a special forum presentation. Part 1 was all about photovoltaics. Today is 5 presentations on a variety of other topics. The first 3 are renewable energy topics. The other 2 are greener heating topics. And we have a lot to cover. So we're going to get going. We'll have probably 10 to 15 minutes per presentation with a little bit of Q&A after each presentation, and then hopefully some time at the end. And maybe our speakers will stay around after the hour and a half is up and answer some more questions. We do have to be out of the room by noon. For anybody interested in the first part 1 of this, there was a video made, and I'm told, I haven't seen it yet, but I'm told it has the audio and the presentation slides. So as soon as that becomes available, we'll put that out somewhere, make you guys aware of it. If you signed in, you'll get announcements, things like that. People who attend the forum tend to get some of the announcements that don't go out to everybody. The sign-in sheet is going to just continue to circulate among the crowd. Okay, so we'll kick it off. The first topic, I'm going to do a couple of introductory slides before we bring up our first speaker, Tom Hoffman. And the first topic is solar hot air. And it's something that maybe a lot of you aren't familiar with, and it may be something that you are and you just don't realize you're familiar with. Anybody who's experienced this knows about making hot air with the sun. And the beauty of solar hot air is that it's very simple. That's the elegance of it. In fact, it's simple enough that it's a very easy way to get into solar power or renewable energy. And in fact, you can even do some of this yourself if you're handy. So I'm just going to show you a few pictures. We're going to bring Tom up, and Tom will tell you about his system. So this is the basics of a solar hot air collector. The sun comes through the glass, heats up an absorber, causes the air to heat up. The hot air rises, draws cool air out of your house as the hot air goes into your house, and it just keeps going as long as the sun hits the collector. Another style, convection driven. You don't need fans to do it. This is a typical commercial unit. It's got a fan built in. You get a little more heat out of it. It costs a little more. And here's a variety of ways you can install these. And there's others if you're creative. It's elegant. It works. They make a lot of heat.
Hello, excuse me?
Yes?
Can we see the slides?
Yep, we're working on, sorry, we're working on that.
Oh, okay. All right, then.
Anyhow, what I find, I do use a system like this, and what I find that in the spring and fall, it helps to reduce your fuel use. In dead of winter, when it's cloudy, may not do too much. So I want to bring up Tom Hoffman, who has one of these systems installed, and he's going to tell you about his system. Tom?
Okay. Are the regions...
When I first bought my house back in the mid-1980s, one of the things I was looking for in-house was the possibility that it had some possibility for solar retrofit. I was looking for a good unobstructed solar south exposure. So I bought my house in 1987. In 1989, you see that triple casement window up there. I had that installed in 1989. Then in 1998, in very early 1998, I had that 4-panel active solar collector installed by a local firm, One Energy. The other possibility when I had that installed was James Duggan Solar Systems. I decided to go with One Energy because they were using mostly off-the-shelf components. Mr. Duggan was manufacturing his own proprietary collector, but that might possibly have functioned better. In any case, I think both those firms are still in the area, although One Energy's contractors have moved away, so I don't know if they're still doing installations. I have some thoughts about active versus passive systems. On the one hand, active systems, they do use energy, although they make far more energy than they use. They do have more moving parts. They're somewhat more complicated. On the minus side, I often during the winter, on a bright, sunny, cold day, when I'm walking around outside, I see a lot of south-facing windows, and the shutters and shades are completely drawn. I don't know if people aesthetically don't like sunlight streaming into their houses during the winter. In that case, they just might not like a passive system. They might prefer to go with active. I am concerned also with birds striking the window. I've actually taped little bits of dark-colored paper inside the window in the hopes that birds would know that's not just an unobstructed empty area. I don't know of any bird strikes on my window, but since most days I'm here at work, I don't know if that has happened when in my absence. Okay, well, I'll describe the active system since that's more complicated. The collectors were made by a firm in Arizona. I don't know if they're still in business or not. As I understand it, they're made out of aluminum. The glass is the sort of glass that, if it should fracture or shatter, it breaks into pebbles as opposed to big shards. Behind that, there's a thin layer of flat black aluminum. And behind that, there are channels so that the air moves back and forth to maximize heat transfer from the metal to the air. Other components of the system include 2 fans. There's one on the bottom at the collector inlet, and then there's another one at the top. There's a controller in the cellar, an electronic controller that controls the whole system. There's an internal sensor inside the collector, so the system will know when it's heated up enough to produce heat. There's a damper to prevent cold air from flowing back out of the collectors when the sun isn't shining. There's a thermostat, and also there's about 25 feet of duct leading from the front of the house to the collector inlet. Let's see if this...
You need a laser?
Okay, can I borrow that, please?
Thanks.
Okay, the collectors are basically set up in series. There's a inlet that I mentioned below there. That's the outlet of the bottom collector. It goes to the inlet of the next collector up from that. And then the warm air goes into the house, first floor. It basically performs pretty well. On a full sunny day, usually the collectors come on at about 10 in the morning. They run until about 3 p.m. at least, even on a cold day. The furnace comes on about 2 or 3 hours after that. The temperature of the air coming out of the collectors, usually it's between 150 and 160 degrees Fahrenheit. I think that's a little too high to be ideal. I suspect that the system would be more efficient if either there were a higher rate of flow of air through the collectors, or possibly if the collectors were hooked up in parallel rather than in series, if they both had their own inlet of cold air and both of them were just exhausting direct hot air direct into the room instead of one collector into the other, preheating it. Let's see. The air coming out of the second collector was formerly higher. It sometimes got up to like about 165 or 170 degrees. I made some modifications to the system. There were some grates on the inlet and outlet for the air. I removed them so that the air could come through more unobstructed. I also rotated the damper in the bottom collector so that instead of hanging vertically, it was more like at an angle. So the full weight of the damper wasn't holding it shut. It would open more easily from the incoming air. I also set the controller. Initially it was set to come on when the collector temperature reached 110 degrees and go off when it fell down to 90 degrees. I lowered the start temperature to 100 degrees so that it would start more quickly at a cooler temperature. Basically, the system works pretty well. In spring and fall, I rely on that as my primary heating system. I turn the main gas-fired furnace off, except on a very cold day or cold night. Initially, I was worried that the air coming out of the collector, it's only about like less than a foot below the ceiling. Initially, I was a little worried that the warm air might cause the ceiling plaster to crack, but that hasn't happened, and it's been about 13 years. That's about it. Oh, I have some handouts, if anybody wants to see them. There's something produced by that other firm, Duggan Solar Systems. I don't know if it's still current. And I have 2 copies of 2 publications that DEC published some time ago.
Tom, what did that cost you back then?
I think it cost about $4,000. The window was about $2,000 to $3,000. Yes?
What is the temperature of your home when you're relying solely on this system?
It varies. Sometimes I let it get down to like about 55 or 60, but I find that the collectors raise the temperature to about 5 degrees, at least 5 degrees above whatever the set point, temperature set point of the main gas-fired furnace is. Yes?
How big is your house?
It's a small house. It's about 1,000 square feet. Combined living room, dining room on the first floor with a kitchen in the back, 2 bedrooms upstairs. The window I was mentioning, that casement window overlooks it's on the upstairs hall and over the stairs leading to the upstairs.
Does that unit mount on the roof directly, or like inside the attic with a window on the roof where it shines through that way?
Well, they're not on the roof. They're both they're on the first and second floor. The active solar collector exhausts warm air to the first floor, and the windows, the south-facing glazing is up on the second floor.
But is this unit a sealed box, like you see solar panels on roofs of houses? Is it something like that just heats up like a radiator, that just lets hot air flow through? Or is it different? I'm confused on exactly what it's like.
No, it's a sealed unit. There are 2 openings in each of the collectors. One for the inlet for the air to be heated, and then another opening for the warmed air to come out.
So
you could mount it on the wall or the ceiling, or the,
Yes, actually I had the choice. I was wondering if I might have to move them sometime because my house is right next to a neighbor's property, and if they planted a big evergreen tree, I wouldn't be getting any solar heat anymore. So actually, there were two possible designs for the collectors. You could have them flowing horizontally, or have the air flowing vertically from the bottom to the top. And I got them in the horizontal mode, so they would have been easier to transfer to the roof if I had to.
there's no thermostat, right? So you just let the
Oh no,
unit-
there's a thermostat.
Oh,
There's
okay.
both an internal sensor. The system won't come on until the collectors have heated up, and there's some warm air to be drawn. And there's also a thermostat inside, just like you would have for a furnace, a gas-fired furnace, so you can turn it on and off that way also.
And what happens when it's off? Then where does the heat go?
The heat would just build up.
Oh.
But that's one advantage of, I think that's one advantage of having vertically mounted collectors instead of at an angle. They don't overheat so much in the summer. And then in the colder months, they just take all the heat that they produce.
Tom, we're gonna have to move on.
Okay, sure.
Thanks, Tom. Okay, we're gonna have the next speaker. We gotta keep moving. Maybe our speakers will stick around. Sorry, Regions, we're working on getting you the video here. There are a couple of incentives for hot air as well, and you'll see throughout the slides today that there are incentives for a lot of what we're talking about. Okay, Jim.
And how do I change the slides
Just
here?
down arrow.
Just down arrow.
Or page down.
What's that?
Or page down.
Okay.
Or down arrow.
All right. All right, this all got started for me back in January when I was heading north with a friend who works for NYSERDA. And of course, we're talking on the way up north and stuff, and he mentioned to me that there's incentives available for solar thermal. And I said, oh, that's interesting. Tell me more about it. And he proceeded to tell me that there's a lot of money available for residential solar hot water systems. So I basically took the initiative and started looking into it. And one thing led to another, and I am now the proud owner of a solar hot water system, which is producing 100% of my hot water needs, domestic hot water. So let's see if I can make this work here. Down arrow. Okay. Most of you already know that there's basically two types of solar energy. There's light energy, photons, and there's radiant energy, heat, and both of those you can take advantage of. The easier one to take advantage of is hot water, because it requires less technology to basically get that energy into usable form. As Kevin pointed out here earlier, you know, if you have something that's just sitting out in the sun, it's going to heat up, and that is exactly what this principle is here, is applying engineering technology to the idea of just putting something out in the sun and letting it heat up. And with the intelligent application of technology, you can do all kinds of wonderful things. Am I too close? Okay. You can basically, you know, make that energy work for you instead of just, you know, dissipating into the atmosphere. So, anyway, some points here are that the slide states that this will cover between 50 to 80% of your hot water demand. In my case right now, it's covering 100%, and I'll explain that a little bit later. And the system costs right there, that is also malleable because there are some incentives available, which I'll get into a little bit later. And you have different companies that supply solar hot water systems, and I'm going to explain exactly why I chose the company I did and what your options are. For me, it's a no-brainer. Solar hot water is the easiest entry for anyone that wants to do solar of any kind. It's a lot less expensive than solar photovoltaic, maybe not as sexy, but you're going to basically pay a lot less money for taking advantage of solar energy with a solar hot water system than with a solar photovoltaic system. This system was installed in late April, and it began operation on or about May 2nd. About 2 weeks later, I decided to turn off the electric backup inside the hot water tank, which basically is there to provide, to make up whatever the sun is not providing if you have like an extended period of cloudiness or so forth. So that electric heating element basically kicks in if your solar system isn't doing its job. Well, I turned off the electric altogether, and it's been off since mid-May, and I've had no problems whatsoever with having enough hot water. Granted, this is a one-person household, so results may vary, but I have not had any problems at all with producing enough hot water. The system was purchased from the Radiant store in Malta. They are a supplier of the Felix solar hot water systems. That's an integrated system. You're not buying a component from here, another component from here, and copying them together. It's designed to work together, all the components, and so you have the confidence that these elements will all work together. Yeah, for residential customers who have electric hot water heaters, okay? This rebate program only applies to people who are heating water with an electric hot water heater. And the big picture idea here is to get people, is to reduce electric demand, you know, in the aggregate. So if you've got, you know, basically